Hey, welcome to Christmas Tech with Aussie Phil. Uh, in this one, this is a repeat of our 5-volt one. So if you haven't watched that, be worthwhile going and having a look at it. But this time around, we're going to repeat it at 12 volts. And we certainly do have a bit of a difference at the end. So if you haven't seen the first one, I'll just very quickly go through the desktop view. Coming in from the left over here, we have 12 fuse array. And we're actually using, unlike I said in the last video, fuses, we're actually using auto reset circuit breakers. This one here that we're going to go through is a 10 amp breaker, so we can see what happens. We have 1.5 meters of standard pixel wire, 20 Chinese gauge, certainly not 20 AWG. And here we've got a thick wire going up to our electronic load so that we don't actually have any real issues with voltage drop going up to the load, and we keep any flames or anything else like that that might happen away from the electronics. We're also measuring the voltage at that point, just so we can see what we've got. So let's have a look at that. As you can see there, we've got, on the left-hand side, we've got 12 volts. That's the voltage being measured at the end there. And the meter on the right shows the voltage and current coming out of the power supply. Behind that, there's a 500 watt 12 volt power supply, so there's no worries about driving as much current as we need to draw it. And we've also got our electronic load, which is what we'll be using. At the moment, because I did do a little bit of a test run on this just to see what happened, we had it up to 13 amps. We'll start at 5. We'll see what happens. So we'll turn that on, and as you can see, we're down to 10 volts at the end of the string, end of the wire, and we've got 51 watts being pulled with 5 amps. So we won't muck around on this one. Assuming I get the right little bit. Let's go to there, and we'll jump straight to 10 amps, which is the rating of the fuse. And I'm sorry if you hear any fan noise or car noise. Car noise is certainly outside. The fan noise is from the dummy load, and you might be able to hear that. As you can see here, we're dropping about 4 volts along the wire, and 4 volts at 10 amps will be 40 watts of heat trying to be dissipated by that wire. And I tell you what, it's already getting quite warm. It's certainly not right up there yet, but it's getting hot. Let's drag that up to 12 amps, which is about the limit of where we were with our 5 volt test, where it dropped to basically a dead short. And here you can see that we're comfortably still drawing 12 amps through that auto reset breaker. So this is a case where the fuse or breaker may not actually help you. Because it's an auto reset breaker, I'm not worried about blowing it. So we got up to 15 amps there. We still haven't blown that breaker. But let's have a look at, I'm just curious as to what the current is. And we are using a thermal camera. Get that. And we're already at 135 degrees Celsius. And the breaker just tripped as well. So there's a case where the breaker has definitively tripped before we've blown any wires. And yeah, they are really 100. Well, I can't tell by feeling it, but I reckon I could burn myself on them. So we'll wind that current down to 12 amps. I might be able to push 13 through that fuse. We'll see how we go before it resets. And as you can see, that it reset itself after a period of time. So we've got 13 amps running through that bit of wire. 5.8 volts, if you had pixels on that, remembering this is a 15 pixel length bit of wire, they'd still be white if you're running 12 volt pixels. So you wouldn't, if you were the other side of the short, it'd be black. But right there, you're probably seeing nice white pixels and not necessarily understanding why you've got the rest of it as a dark string. But I can guarantee you, the The rest of it's probably going to get very hot. Now, we've got smoke starting to rise. You may not see that on the camera, but I can certainly see it here live. Let's grab a thermal image of that and see where we're up to. And yeah, we're reading at points well past 140 degrees. We're still smoking, so I've got a thermal image where it's 140 degrees. I'm going to let that run for a minute and see what happens. Breaker tripped. So there we go. What we'll do is, yeah, it's still smoking. So it hasn't caught on fire, which is probably a very good thing for us to have not occur. It is sitting on cement sheet, so I wasn't particularly worried if it did. Just turn everything off and away we go. The fumes from the PVC smoking or the covering might have been an issue, but luckily that's all blowing away from me, so I haven't smelled it at all. So just crank that down and we'll turn that off. The load has the ability to provide short circuit. I'm very curious how long it takes for the circuit breaker to trip. With a bit of luck, it should actually be instant. So if we would actually have a short on this cable, let me press the enter button. Everything's probably still very hot, but that's okay. Let's see how we go. All right. Whoa, 25 amps, and you've seen the circuit breaker go. So, yep, that was interesting to see that. So, thank you all for that, and we'll see you on another video.